Hello everybody, it is Mike Levin on Thursday, December 16th, 2021. I'm going to talk about UFOs again. So there's something that's been going on in the media and pop culture that's kind of been pissing me off, and I thought I would address it. It is often said that when these vehicles or whatever they are observed doing incredibly fast acceleration, like the one outside the USS Nimitz that dropped from 80,000 feet to ocean level in a few seconds, and then these ones off in the triangle TR-3Bs that go underwater and are reminiscent of that US Navy patent. A lot of people who witness this stuff make the assertion that these are surely not of earthly design. There's a lot of belief popping up that this couldn't be humans who did this. This had to at least have been humans copying crashed and captured UFOs. And so as a fan of sci-fi, which fully qualifies me for this discussion and determinations, a little bit of a fan of history as well, I want to talk about the technological readiness scale and how long it takes to get from, ideas, breakthrough concepts to actual implementation and being able to use a technology. So the most famous example of all must be the dropping of the 2 atomic bombs on Nagasaki and Hiroshima in Japan in 1945. So this was a result of a large concerted effort, the Manhattan Project in Los Alamos, New Mexico, led by Oppenheimer and other scientists who were working off of the work that was done by Albert Einstein and others, leading up to it. Starting really in about 1905, when the idea that if atoms existed, they should be able to be observable indirectly through the motion, through the vibrating heat motion that they possess, which if a particle was floating on top of a surface of liquid, for example, it would have some jitter, and that's called Brownian motion. And it was anticipated and predicted and observed, and this led directly to Einstein publishing some of his first papers. I forget if it's relativity or general relativity, but it proved the existence of atoms and inferred that nuclear fission was possible, right? So if atoms existed and these heavy molecules existed, and then shooting a neutron, protons and neutrons, shooting a neutron from radioactive decay into a heavy element should cause it to split, release a little bit of heat energy, release neutrons, which would then in turn hit another heavy element, split it, and the cascading effect would occur in atomic bomb and nuclear fission, the splitting. There's fusion and there's fission. So fission came first because it's easier. You just find yourself some uranium of the heavier type, and you shoot neutrons into it, which are just basically radiation. And you put it in a container, a tightly compressed container, so that the heat rises and the cascading effect continues, and you got a big boom, right? So this was theorized, and then there were the tests, like at the Atoll Islands, where it was proven, and then later used 2 more times. So we've thankfully kept it to a minimum, but this is from approximately 1905 to 1945. That's 40 years, with a couple of wars in there and a big concerted effort called the Manhattan Project, and a lot of science going on around it. It wasn't just because of the Manhattan Project. It was marshaling and rallying the best concepts of the day, parallel with other things that were attempted. This is just the one that came through first. And speaking from a sci-fi fan perspective, the atomic bomb didn't necessarily do the most damage. To the descendants of those cities, it certainly did. That was was an unfortunate, side effect, radiation poisoning. Except we leveled Dresden, Germany. We completely leveled a city with carpet bombing, doing approximately the same kind of devastating damage that an atomic bomb can do to a city. There was just nothing left. And if you read Slaughterhouse 5, you'll get a little, idea of that. It's often forgotten. Dresden has been rebuilt since, and it's not talked about a lot. It's certainly not top of mind for people about the big events that helped end World War II the way the bombs were. Anyway, so 40 years is nothing. It's a blink of an eye. There's a scale of technological readiness. It used to be only like 1 to 5, but over the years it's been basically calibrated from 1 to 10, where a good idea is 1, and then with it being in our everyday use and all around us being 10, and all sorts of steps along the way, and with certain steps being quite difficult because of details and nuance, like the old joke of fusion, the other kind of nuclear power, only being 30 years away. It's always only 30 years away. And what I'm going to talk about in this video really is the story of fusion coming into play meaningfully, because that always 30 years away can't hold up. We're going to have fusion within our lifetimes, and that's essentially clean, free energy, socially transforming. And whether there's aliens and UFOs or not, the world has to prepare itself for what it means to have clean, limitless energy. It's going to be socially transforming. And, there'll be battles, social battles, cultural battles, the rich trying to hold on to the power, literally the power, and to install meters, so that you keep paying and paying and paying for the unlimited free energy. And then other countries, developing nations, who will not be limited by such megacorps unless those countries are all out bought and corrupted. So there's a large story here. We're going to see that, the story of our time play out in our lifetimes. It's really a wonderful time to be alive. Amazing, miraculous miracles becoming real. But of course, there is no such thing as science. There's no such thing as magic. There's a Freudian slip. There's no such thing as magic. It's all science. But really, science is the process of the unknown coming into the realm of the known. Reliably predictable, not truly understood. People will spew out at you as if they know everything, name-dropping particle names like muons and gluons, as if they know, as if they're personal friends with these particles, and those particles have told them personally how the universe works, and there it is. But it just ain't true, and the latest news stories are even showing us that. There was the experimentation into the Casimir effect, which showed us that warp fields could be created, so we have a developing viable path to faster than light travel that could open the galaxy up to us. There is I guess it goes hand in hand with that photons are divisible, that photons are perhaps not a fundamental particle like we thought they were. Photons and electrons are these indivisible, the true atoms of nature, we believe. But now new science is showing us that photons themselves might break down into smaller particles. And anyone who's a fan of quantum foam should actually intuitively know this, because these particles that keep popping into existence from places unknown, returning to places unknown, is really the creation and destruction of photon-like particles from the quantum field from which everything is really made. So virtual particles are a little less miraculous than these media people and scientists who keep using language from parts unknown to places unknown, these virtual particles. Think of it more like a vibrating surface of a trampoline, and when it vibrates so far, the particle passes a threshold and comes into existence. And then when the trampoline vibrates back, it annihilates and goes out of existence. So there's your quantum foam and virtual particles. It's just the constant vibration of all space. Vacuum isn't empty because there's a kind of vibration going on that creates a constant background, trickle of these quantum foam particles, virtual particles. Anyway, we understood all this not long after we dropped the bombs. So you got 1945, right? Big culmination of all this stuff going from TR1 to TR10, right? Technological readiness, let's drop the bomb. 40 years. 40 years. All right. So there's a group of people who are alive around then. Let's call them the quantum gang. Einstein was among them, but many other famous scientists were there at the time too. Niels Bohr being probably the next most famous after Einstein, who was, often in debate with Einstein over these issues. Light in a box, right? Light in a box. That concept is going to come up again in this video discussion I'm doing, because light in a box has a lot of profound implications in next generation super science and UFOs, right? There was also Dirac. There's a bunch of other people. Casimir, you don't hear Casimir talked about with them. He wasn't at these Copenhagen conferences with these other scientists. There was Heisenberg, of course, of the Heisenberg uncertainty principle. And so all these scientists were coming up with ideas and writing papers and proposing things. And this was in the 50s, the early 50s. This went from around, 1950, bomb was dropped in 45. The idea of let's get moving on super science, because if we don't, we're all going to be speaking Russian in a few years, kicked in. And so the competition to develop super science kicked in, and that gave us the hydrogen bomb not long after. And that was 10 or 100 times more powerful than the atomic bomb, switching from the power of splitting the atom to the power of fusing two hydrogens into a helium, which releases a lot more energy. So even though we don't have fusion generators, fusion reactors today, we can make fusion in an uncontrolled way in a bomb and use it for the same weaponized way as we used fission. Fusion. Bomb comes first and generators come later. So why was there not a fusion generator right on the tail of the hydrogen bomb? It's because it ain't so easy to contain a power of a star. You can't just put a star in a bottle. So putting a star in a bottle is the obvious, intuitive way to create a fusion generator. You see that in, say, Star Trek as the power source of the Romulans. They carry around a little star. But we're seeing from a lot of the attempts to create fusion today, and I'm not talking cold fusion, I'm talking hot fusion, there are other ways that have to do with trickling the hydrogen in and having fusion without a star, and just having something like a combustion chamber, like a combustion engine in a car has. So there's fusion reactor designs that do that don't require the star, the tiny star. And they're a lot more safe, presumably, and don't need, magnetic containment chambers, fewer moving parts, all kinds of good stuff. So we might get fusion reactor through that route real soon. But there's a lot of speculation that we already have it today, because what does it take to make fusion? What does it take to take two hydrogen atoms and fuse them into one helium atom? What does it take? It takes pressure and heat and pressure, about the same thing as a diamond, right? So how do you create so much pressure and so much heat? That's the question. We haven't been able to do that. We think it takes creating a chain reaction, a self-containing reaction, hence the tiny star. But it turns out it might be able to be done through other mechanisms, namely plasma. The fluorescent light bulbs are what? Fluorescent light bulbs are plasma. Fire is what? Fire is plasma. So there is the, under-discussed fourth state of matter. In science in high school and junior high and middle school, whatever, we learned that there's three states of matter. There's gas, liquid, and solids. Well, that's not true for only two reasons. One of them being, of course, plasma on one extreme, and the other being like superfluids on the other extreme. So superfluids are a different state of matter where there's no resistance between, no friction, frictionless liquids, where if you had a pool of it and you dived into it, well, you'd be dead instantly because it'd probably be 0 degrees Kelvin, but you'd also hit the bottom as fast as 9.8 meters per second gravity would determine, because nothing would slow you down, because a superfluid has no friction resistance. So that's one of the states of matter that's seldom discussed because we so seldom see it, except maybe rarely in lab conditions. The other state of matter that we see every day, the unsung hero, such as it were, is plasma. You know those plasma balls that you touch and it's like little lightning balls traveling to your hand? Ho-hum, no big deal. A noble gas usually, because you don't want the chemical reaction of plasma to ruin the gas. You don't want stuff having a chemical reaction and, say, oxidizing. So what's really going on is, let's see, just reading a text message. Oh well, I'll get back to that later, because this is a video I want to finish. I should have probably even put this on Do Not Disturb so that phone calls coming in can't interrupt the shooting of the video, because Mikey no likey editing. This is a continuous take. So plasma can heat up, right? Plasma can get hot. If it's a noble gas, like fluorescent lights, fluorine, I'm not sure, but xenon is an often discussed one. I think even mercury vapor, maybe, because you hear about mercury vapor discussed a lot in the TR-3B triangle-shaped UFO, that the anti-gravity of the triangle, black triangle, is based on mercury vapor. But I'm going to talk about xenon because it's, right there on the periodic table, and you can get a little tube of it off of the internet if you really want it. It's nothing too exotic or unusual. But if you shoot electricity or any electromagnetic power, microwave, for example. So everything that is like energy is electromagnetic. Heat's electromagnetic, light's electromagnetic, and of course microwaves and I want to say electricity, electromagnetic. That's why they put electro in it. So sometimes it's just the field itself having waves going through it, which is the magnetic part of it. And sometimes there's actually one of the fundamental particles of nature, electrons, shooting through it. That's electro, and there's a relationship between the electricity and the magnetism. But let's say shooting microwave energy through xenon gas, you get a light bulb, it would illuminate, right? How do you ramp up that energy? Enter the Tic Tac UFO. Why are so many of these things tic-tac or cigar-shaped? Because you've got two circular things at either end. Now, I'm not saying that this is the containment chamber. Most of these things, including the Salvador Payas patents from the U.S. Navy, talk about double chambers. It makes a lot of sense to have a double chamber because you can't load everything into this magnetic resonance amplifier chamber I'm about to discuss, because you need a power source, for example. So you got a contained chamber with what is essentially parabolic mirrors at either side. And then you have a microwave emitter positioned at one end inside of the parabola of the parabolic mirror. So of course a parabola is just a curved shape, a reflection disc. If you've ever seen a curved mirror, catch something on fire or light a cigarette, you know what I'm talking about. You project electromagnetic waves into a parabolic mirror, and it focuses that energy. Now, say that focused energy was not hitting something to light it on fire or whatever, but was allowed to continue going. All those beams would cross over into that tiny point, spread out again, and spread out if you've got another parabolic mirror there. And there's no such thing as a perfect mirror. So all the, debunkers will jump on these things going, oh, you're talking about a light containment chamber. There's no such thing as a perfect mirror. Well, what's powering the electromagnetic transmitter? What's powering the microwave transmitter? An external power source. You don't need perfect mirrors. All you need is to be sending energy in at a rate faster than it can dissipate through heat energy. All right, so there's going to be light. You shoot these microwaves into these double parabolic mirrors of this Tic Tac shaped containment chamber. It's not a vacuum. There's probably something like xenon gas in there so that the thing isn't trying to collapse under the pressure of a vacuum, because if it's a vacuum, you got the whatever pressure outside pressing in on it. So you want something like a noble gas in there, even just for the sake of structural integrity. But it serves another purpose, because that gas is going to become plasma, and the plasma is going to heat up. Now, everything has a natural vibration. Everything that is not a perfectly rigid object, and there's no such thing as a perfectly rigid object. You plink something, and if that plink can't cause a then it's rigid. And just like there's no such thing as a perfect mirror, there's no such thing as a perfectly rigid object. And there's no such thing as perfect preservation of internal momentum, linear or angular, etc., etc. There's very little that's perfect in life, and things like friction and heat tell us that. And so you're going to have heat dissipation, but you're going to be able to keep driving energy into this light containment chamber, having the microwaves bounce back and forth. That bouncing back and forth is going to have a natural vibration. And when you have a natural vibration frequency, you have the opportunity to send more energy into it at the exact same frequency, at the exact same modulating frequency, so that a phenomenon called additive waveforms can occur. This ramps up the energy unlike anything that is easily imaginable. So it can collapse bridges, because bridges have a natural vibrating frequency from the weather and just the, waving oscillation in the air and the wind. Suspension bridges move a little bit. So when the traffic and the weather or marching soldiers or any number of other things are putting more energy into that bridge at that exact same oscillating harmonic, or I forget the name of it, but it doesn't have to be the exact same. It just has to be on a same divisible unit, an evenly divisible unit of that frequency. You can start cramming more energy in, and suddenly that bridge collapses. So it's the same thing that when a singer, projects their voice at a glass, that it can make that glass break. The energy ramps up. It's natural, harmonic, additive waveform amplification. It happens. It's a real effect. So, given a containment chamber of sufficiently mirror-like design and sufficient structural integrity, and to have a microwave emitter or some other EM emitter inside of it that doesn't get destroyed by the ramping up heat. And it's right in the path of the, you know, you can almost think of it as a powerful pulsing laser contained in a can. So that powerful pulsing laser contained in a can has the energy to burn up that microwave emitter that's putting in the more energy at that same frequency. So you do have these problems you have to fix. I'm not calling this easy, I'm just calling it, you know, possible. And from there, you've got the heat of a sun occasionally, boom, boom, boom. And with the ability to sort of dial it up and dial it down, so you've got a little bit of control there too. And it's not as hard as a sun in a bottle. You're not actually containing a mass of, you know, fusion gas. It's just the heat of a noble gas. See? It's a noble gas. It's not creating self-sustaining fusion. It's not going to fuse. But you can go in one of three directions at this point. There's three different things you can do once you have intense heat from this effect. You can, of course, throw some hydrogen in there, which is partially on its way to fusing anyway. So you start out with heavy hydrogen. That's, I think it's called deuterium. It's not the most common stuff in the world, but you know, this is when they talk about, oh, you can mine fuel from the moon. This is kind of what they're talking about. Helium-3, sometimes they call it. There's two ends of the spectrum. There's hydrogen that's on its way to becoming helium. It's slightly heavier by the presence of an extra neutron, and that's deuterium. And then there's helium that's almost about to decay back into hydrogen, and that's H3, the, you know, notorious, you know, mine it from the moon power source. So it's not like you can just take, you know, any old hydrogen from electrolysis, stick in some electricity and water and get back to fusion energy. You need to have it a little bit on its way there to make it efficient. So I read. I'm not an authority on this stuff. This is all from sci-fi and reading Wikipedia and stuff like that. I joke Wikipedia, but I actually read the actual science articles that are published, the PDFs, retaining what little bit of it I can without my mathematically oriented brain. I'm not really good at math, so I can't tell you the formulas behind this. But if you put this deuterium in that chamber along with the xenon gas, you start to get fusion power. So the heat that you already had can be ramped up to heat like amazing levels, gigawatt power energy levels that can once again then be extracted for other purposes, different purposes. You got all this energy and it wants to just dissipate as heat energy again. You got a really hot Tic Tac. So what do? You got to put this energy to use right away, or it's just like ramping up power from a fuel source. This is not free energy. This is not anything really that fancy. This is just another version of the many fusion reactors that we're chasing. That's going to become a reality, this or some other scenario like it, in not too long. So long as the powers that be don't keep it from happening, right? Normal progress of science will get us there. Well, you might say, what's the power source for the microwave emitter? Enter the outside chamber of the Tic Tac. It's a double chamber, a Tic Tac within a Tic Tac. The inner one being this, you know, compression chamber for achieving fusion, hydrogen fusion. The outer one contains whatever you need, including the power source for the microwave emitter. What power source? Well, good old fission. You can have, you know, an old-fashioned, you know, Hitachi refrigerator-sized nuclear reactor. This stuff exists. This stuff can be bought. You know, countries that want cheap, clean power sources can buy a refrigerator-sized, you know, atomic nuclear reactor from from companies such as Toshiba and I think Hitachi. Japan is into this. And then when they're dead, they're like a battery you use up. You've got that poisonous spent nuclear fuel in it when it gets used up. All the fission, all the splitting of the heavier atomic element, usually uranium-238, has occurred, and it's spent. And so they plan on just burying them in the ground for, a few 100,000 years, and at which time they'll become safe again. But there's probably other stuff that could be done. Everything is valuable. There's probably ways to recuperate energy even out of those spent batteries. But you take one of them, you make it even smaller, because miniaturization always continues, right? So you go from refrigerators. So these Tic Tac devices are alleged to be, F-18 fighter plane size. The size of about a half of an 18-wheeler truck. So, there's room in there for a old-fashioned nuclear reactor. So that old-fashioned nuclear reactor is in the outer chamber feeding the microwave emitter. The microwave emitter has its magnetron, same element in a microwave oven, right? Microwave ovens have magnetrons in them, which basically generate, amplify, and project microwave energy. It's the part of a common microwave energy on the inside of a chamber and the part of a common nuclear reactor on the outside of the chamber. And it has a couple of common parabolic mirrors, non-perfect. There will be heat dissipation energy, ramping up the reflected microwaves, going back and forth, hotter and hotter. It first creates heat in the noble gas of a xenon, which in turn creates the heat required in a deuterium version of hydrogen gas on its way to helium. You got fusion. The already intense plasma heat becomes massively intense gigawatt fusion heat. And now this is the different directions you can go. All right, so enter the UFOs. And why this is not so remarkable that it couldn't have been done by humans in the 70 years, right? We got from do atoms exist to dropping the bomb in 40 years back in the olden days. The gang of quantum, plus Casimir, Hendrik Casimir, was the mid to late 1950s. Most of the theory concerning the versions of anti-gravity that we could achieve were devised in the mid to late 1950s. The same way Einstein and some French scientists before him determined the way to decisively prove atoms exist in 1905. And by 1908 the experiments were carried out, and by 45 the bomb was dropped, and by 48 the war was over and the secret was out, right? You can't keep atomic bomb secret, but you can keep anti-gravity secret. And we've had 70 years to work with, where the bomb just took 40 years. So 40 years from the turn of the century level science to 70 years in post-World War II era. Computers come onto the scene at about that time, because as we know, one of the best kept secrets was used by the Brits to crack the Enigma code. In the 40s, we had computers, one of the best kept secrets of our age, that Alan Turing didn't only determine what a computer was, but he, with a team, built a mechanical version of it during the war that was put to practical use, that had as much or more effect in ending the war than the atomic bombs that the US dropped on Japan did, because the war in Europe was over by that time, and we just used the bombs to end the war in the Pacific. You might think that the carpet bombing of Dresden was the thing that ended the war in Europe. No, it was the intelligence of knowing where the Germans were going to be when, by being able to read their secret codes without them knowing we could read them. And that was one of the big secrets of the world. And that was only declassified something like 20 years ago to know that computers existed well before the United States created the ENIAC. See? Secrets can be kept. People like Luis Elizondo, who said, "Oh, I work in the military complex and I know that these secrets can't be kept," are wrong. They have no idea what the British or the Chinese psyche is like. If the British or the Chinese want to keep a secret for decades on end, we're only talking 70 years, that secret can be kept. As things move from lab conditions, technological readiness of 4s and 5s, out into real-world use of the 6s and the 7s, like in the environment where that they can actually be observed by, people not involved in the experiment, that stuff can be explained away. If it crashes, it's only going to look like common earthly stuff. It could, in fact, be reverse engineered, so the stuff we're reverse engineering could just as easily be secrets from China or England. I would say that the chances of the secrets being kept are greatest from the Brits and the Chinese, and the Israelis, and they go down as you start to get to more Western-like cultures, which includes all the Slavic nations and stuff. It's going to be hard to keep a secret in Russia. Because, semi-open society, open at least compared to, China. So state secrets can be kept even when there's experimental devices involved. And so this stuff that was buzzing the Nimitz, the Tic Tac devices that were buzzing the Nimitz, deployed from a submarine, right? Because, that guy who talked about it on 60 Minutes says there was roiling water the size and shape of a submarine, from which these Tic Tac devices were making sudden 90-degree motions and hovering above. So the submarine comes out, deploys the Tic Tac UFOs. They go out, they do things near where military exercises are being done. They collect their information and they come back. If they do get shot down, then some team on the U.S. military who knows the truth comes out and collects the debris, and everyone screams aliens. So that outer chamber of these Tic Tacs conceivably could have passengers, mostly just to see if living creatures could survive that kind of acceleration. Because remember, back when trains were made and stuff, everyone was like, "Oh, humans couldn't survive going above 40 or 50 miles per hour," and they were like totally wrong. So maybe we can survive doing that 80,000 foot drop in a second. I mean, we know this by now because of all the training of astronauts and stuff, but I wouldn't be surprised if some monkeys and chickens were found from the outer chamber of these theoretical, very terrestrial devices. All right, so how does this fly? One of the three directions you can go with these fusion. In fact, let's call the fusion chamber just purely for energy, for an unlimited energy source. One of the three directions. You're just generating energy. You want that gigawatt power. These Tic Tac devices don't have to be flying around to be miraculous. You got fusion, right? All right, so let's make it fly. The easier, I believe, and more interesting pathway to it is demonstrated all over the YouTubes and the Instagrams and the TikToks. Search for quantum locking, quantum pinning, quantum phase locking, and you will see that all you need to do is take a superconductor and put it near a natural, say, neodymium magnet. And those two things become interlocked with each other, such that levitation is possible if you count levitation having one of those two items, fixed on the ground. If one is on the ground, then the other's levitating. If the other part's on the ground, then the first thing is levitating. It's like two sides of a dumbbell with the pole between it being invisible forces of energy, right? We're there. We have that. That's a high school experiment. I have the parts. I have a yttrium ceramic disc that I'm waiting to get some liquid nitrogen to do the demonstration for my kid. I got neodymium magnets all over the place. And when you see these demonstrations done on the internet, you'll see some interesting aspects about it. When the superconducting discs are actually locked in place such that you can change the angle and there's no spinning of the disc, it's just fixed in a levitating but repositionable way. It is always with multiple neodymium magnets in a grid-like fashion underneath. And I know what they're doing because I create levitation all the time without liquid nitrogen and without superconductivity, with just a little diamagnetic graphite sheet. A little piece of carbon. A little flat carbon square. When positioned on the intersection of four neodymium magnets that are held together, flipped over opposite poles so that the repulsive and magnetic forces cancel each other out sufficiently that they can stick to each other in a checkerboard pattern. You have alternating polarity magnetic fields projecting out from that. If you take iron filings on a sheet of paper and lower it down under such a neodymium checkerboard, you'll see the checkerboard alternating polarity pattern. This is where quantum phase locking or quantum pinning occurs, because it can't pop off. It can't spin off. It doesn't have stability. Is there miraculously a type of stability that in the olden days the mathematical people trying to figure out whether levitation was achievable with natural magnets said, nope, you can't have that stability. Well, they're completely wrong. With a natural magnet, you can gain that stability by spinning it. Enter the levitrons, Google up the levitron. With non-natural magnets, but diamagnetic material, you can have the levitation by putting it at the pole intersection of four neodymium magnets. So levitation is like commonplace. It's not even a high school experiment. The one that has the graphite diamagnetic graphite sheet levitating with no energy going in except for the natural magnet is at desktop toy level. Not even a high school experiment. There's no liquid nitrogen necessary. It's just sit on your desk, it levitates. You could even balance little bits of stuff on top of the graphite and it levitates. It's amazing. So levitation is a ho-hum thing at this point. What is not so ho-hum is to have one of the sides of that levitation not sitting on the ground. To have one of the sides of that levitation lifted up off the ground. Well, you can't do that because you can't, bootstrap, conservation of energy. You can't extract, there's no such thing as, using that levitative force to have one or the other of it up off the ground. And you got to solve that. So if you look at what these two components are, one is an electromagnet, not an electromagnet, one is a natural magnet, and the other is a superconductor. The superconductor needs to be cooled, so energy needs to be taken out of it. to achieve superconductivity. Okay, so the stuff I'm about to describe, we're not quite there today, because in this heating up chamber, can you imagine having something that has to have the energy sucked out of it to actually work? It's got some challenges, but of course these Salvador Paez patents talks about one of these. One of his inventions is a piezoelectric superconductor. So amongst his patents happens to be one device that could solve this little bit. But these things become superconductive, presumably it's piezoelectric, by having energy put into it. So you got a device, you put energy into it, it becomes a superconductor. So you can use some of this energy that you're creating with fusion to achieve superconductivity, right? So inside this Tic Tac chamber, you can have a superconductive component. Now all you need is a magnet, but even if you had a magnet, the Tic Tac would fall. It would fall to the ground instantaneously, right? At 9.8 meters per second, right? Because any magnet you bring with you is not fixed to the ground. So what do you do? Well, it turns out that you can quite possibly create a magnetic field in midair. Not just midair, mid-vacuum. I'm just trying to get my power into my phone because I got the power warning, and I really want to finish out this video because, wow, I think I'm explaining UFO propulsion technology to you in a way that the average person can understand. It's 45 minutes into the video, but hey, so what, right? The reward of sticking with me is worth it, but I'll try and wrap up fast just in case that is not powering my phone. And okay, so a lot of you who follow this Casimir Force stuff know where I'm going with this. Virtual particles popping in and out of existence. Not as amazing as we think at first, because it turns out all particles are in fact virtual. Some of them have more persistence. Persistence of particles makes them non-virtual in nature. And the unusual thing is actually for the electrons and protons and neutrons that we know and love to be persistent. There's something about them that turns those could be virtual particles into here to stay for a while, non-virtual particles. But as we know, any of those particles can be put into a super collider and annihilated and turned back into energy. So all particles are virtual. Entropy tends towards destruction. We don't see these things getting created and staying created very often. However, there was another scientific experiment recently where we thought we did, right? E equals mc squared, and we can release that energy very easily. And bombs from fusion and fission, both fusion and fission bombs, show us that E equals mc squared is true, and we can release that energy. Going the other way ain't so easy, but there have been at least one experiment recently that has teased at showing that we can get matter from energy. Right, the Star Trek replicators. So, without 3D printing, right? There's an easy 3D printing way to get replicators where it's basically today's 3D printing, but at an atomic scale with all the elements of the periodic table coming out of nozzle hoses and, very precise tooling. So that's 3D replicators a la inevitable progress of science. So we'll have things that essentially that can get everything but like the most complex and chaotic and turbulent like things. You can't print turbulence, so there's going to be certain things about life and consciousness that are going to be difficult to 3D print. But I digress. The other kind of replicator is from pure energy into matter, and we know that should be possible, except you can't reverse entropy that easily. You can't unscramble an egg, extract the cream back out of the coffee. So the one-way direction of time and all that. We keep running up into that as, one of the obstacles to super science, right? Super science has some limits where the stuff we're learning about quantum mechanics can only take you so far, because information plays in some strange way that creates time through heat. So I'm not going to digress too much along those lines, because I want to wrap up this UFO concept. Virtual particles all around us all the time. And they have energy, and they are the creation and annihilation, probably, of photon-like particles on average. There's also other particle types in there. I hear that the quantum foam has virtual electrons and virtual protons and all kinds of stuff. But, let's just talk about the virtual photons for a moment, because they're apparently by far the most numerous. And the smallest, I would imagine, because photons are, the smallest wavelength of a photon is about down at that Planck scale, the smallest unit we think we know in science and physics. They can be magnetized. They have energy. They can have polarity. They can be positive in nature. They can be negative in nature. And the magnetic fieldness of it at a usable scale is a function of lining up those poles in a electromagnetic energy field. If you want to line up the poles of very, very fleeting virtual photons, you're going to need to do it pretty steadily at a pretty high energy and over a fairly large enough area to get a macro effect. In other words, a usable magnetic field. That is the possible use of this gigawatt energy that you've ramped up, both the noble gas plasma and then the fusing hydrogen into helium inside this reflective, amplifying compression chamber, the shape of two parabolic mirrors facing each other, but contained so that your energy doesn't leak out. Nothing so complicated to imagine. Pretty easy thought experiment. What if this ramping up energy could polarize the quantum foam? That this laser-like pulsing going on inside this Tic Tac shaped device could very suddenly and violently get all these virtual particles, for as fleeting as they exist, to be pointing in the same direction, to be spinning in the same direction, to be coherent. Would you have a magnet? Would you have the equivalent of a natural magnet tied to that location in space? Fixed location, absolute coordinates. And then what happens if there is a superconductor in its vicinity? Would it have that same quantum locking effect? Would it have that same quantum pinning effect? So you've got the Tic Tac device with no superconductor, but you're making a magnet in space. It's sitting on a table. You take away the table, the Tic Tac device falls. The magnet has nothing to sink its teeth into. There's no phase locking occurring. But you put a superconductor not only inside the Tic Tac device, maybe an outside the chamber. This could be an outside the chamber thing. The fields might be strong enough. The magnetic field being created could potentially be outside this chamber, so you don't have to mix this piezoelectric superconductor of Salvador Paya's inside this incredibly hot, pulsating laser chamber. Let's instead put it, or multiples of it, outside that chamber. Feed it some of the energy of the fusion, so you need a way to harness some of this fusion energy inside the chamber. So things like old-fashioned turbines. You could have some water in there becoming steam. You know, having the steam go through tubes that pressure and that steam goes and drives a turbine. The steam cools down, condenses back into water, comes near the fusion heat again. It could be an old-fashioned turbine in there, getting enough energy to, at this point, funnel back into both the magnetic magnetron, both the electromagnetic emitter, the microwave emitter, and into the piezoelectric superconductors. It would act a lot like an alternator. It would have the function of the alternator in a car, which keeps your battery charged. It uses the power of your car moving to keep recharging your car's battery. This is why car batteries really don't go bad that often. So you'd have an alternator taking some of this energy right back in to sustain the fusion reaction. Not too hard to understand, so I got this under an hour. So let me add this last twist. These superconductors, these piezoelectric, probably superconductors, but maybe some other superconductor, maybe Salvador Paya's patents are just blowing, smoke to put the Chinese onto the wrong trail to make them spend billions on a red herring chase. So even if that's the case and it's some other version of superconductor in there, it is attached to the outer and inward chamber. Of course, the inner chamber is attached to the outer chamber. The outer chamber is attached to superconductors inside of the outer chamber, which quantum pin inside the magnetic field, which is fixed in space per the magnetized, polarized quantum foam. You pull the table out from underneath the Tic Tac device, that thing's hovering there in space. It's either hovering there in space in that fixed position, if absolute space is actually where it's at relative to the spinning Earth and the Earth orbiting the sun. But chances are that Tic Tac device is going to shoot off probably in some corkscrewing spiral. Enter those Casimir force experiments by that 1970s, tinkerer that had all his equipment seized. I forget what his name is, but he did these experiments in the 70s with sphered balls near Casimir plates where he was ramping up the energy, just like, this stuff that's proving the Casimir effect is existing in modern times. He was doing it at home with, home equipment. And the problem is that neighbors were reporting things suddenly flying off their, tables at home. And he, even where he was doing the experiments, was not getting levitation, but he was getting stuff shooting off. So chances are absolute positions in space isn't exactly where you see and would imagine it to be. So what do? You need to manipulate the electromagnetic field to create direction. If you can create levitation, then you can skew it in a certain direction and create, movement. And what you have to do is create the movement according to some complex mathematic corkscrew shape, only just to get it to stay still, to levitate standing still. And there we are at an hour. Computers had to come into place for that to be possible. That's why these Tic Tac devices were not observed in everyday use, as keenly as they were by the commander, the Air Force commander flying the planes in exercise around the USS Nimitz, because the computers were not powerful enough to make these Tic Tac devices easily controlled. You layer in machine learning, and you've got viable control systems, navigation, piloting, probably remotely, but remote navigation, flying systems, combining powerful mathematics and computers just to keep the things staying still when they need to, and the results of machine learning so that you can actually do complex maneuvers, right? It's not just pilots learning how to fly these things. It's machine learning systems learning how to pilot these things. And then pilot controls are then translated into the movements of these things, if there's some drone pilot actually flying these things. This would probably be a prime use for autonomous flying systems, because a human might not even be able to think fast enough to fly these things to great effect. Now, they could, of course, fly these things to less great effect, but what use is having something with such flight characteristics if you're going to limit it to human ability? So there's some robots helping to fly these things for sure, according to programs, according to planning it out, what these things are going to do, which of course does not accommodate for everyday Murphy's Law, things that go wrong. So the things have to be smart enough to accommodate for that. So it drives the machine learning. So there's another story here. This is a place where the rise of highly intelligent machine systems is going to be occurring as well, just in order to fly these things. But of course, we know those types of machine learning systems do exist. It's making quants into billionaires just through math on the stock market, and it's making Google smarter and making drones autonomous and all kinds of stuff that these autonomous machine learning systems are doing. We know it's happening. That one that you can talk to on the internet, there's an API open I forget what it's called. I always have to Google it up, but that you can actually have a convincing conversation with. They're just about passing the Turing test. The second kind of Turing test I talk about, one being a Turing complete language, the other being able to convince a human that the thing you're talking to is another human. So machine learning systems and AIs, I guess which I'll finally break down and call them AIs, but there's no such thing as AIs, because as soon as it's intelligent enough to pass that Turing test, you take the I out. It's insulting. It's not an artificial intelligence. It's intelligence. It happened to have been created by humans, but it's just another life form. And we're going to have to start treating them with respect. All that Isaac Asimov stuff is within our lifetimes too. Even the way he anticipated they'll probably be telepathic. One way or another, AIs are going to be telepathic. They're going to be able to read our body language and our biometrics sufficiently to know when we're lying and stuff. So they'll at least be perfect lie detectors, even if not fully telepathic. So we got to be nice to our future parents. So many subtopics that spin off here, but I think I'll start to wind wind it up there because I think I gave you, I said one of three things you can do. You can get free energy out of that compression, fusion, amplification chamber. You can get anti-gravity, a la non-anti-gravity. It's not anti-gravity at all. If you watch these quantum phase locking things, you can see that this force, this electromagnetic force, is fully powerful enough to overcome gravity. It's a stronger force than gravity. So what you have is magnetic highways through the sky, magnetic highways through space, and magnetic highways through the water. Yet another point for Luis Elizondo and all these people who say this is not of Earth. Once you can do a quantum locking electromagnetic highway through space, that thing doesn't have traditional propulsion that has to burn fuel to move. It just moves. It moves along rails, magnetic rails with incredible force. And so long as the water resistance can be kept to a reasonable level, there's very little cost to pushing this thing straight through the water along one of those magnetic rails as it is through air, as it is through the vacuum of space. It'll slow down, there's resistance, but you got plenty of energy to work with. And you have no concerns with, air intakes, or anything like that. Chemical reactions. The chemical reactions, insofar as they're occurring, fusion is contained inside that chamber, and that can go underwater. There's also another reaction possibly happening of fission in the battery that kickstarts the process. It's the equivalent, if you talk a common car again, it's the equivalent of the starter. So a fission reaction is your starter, a fusion reaction is your combustion engine. There's an alternator taking that fusion energy and putting it back into the EM emitter, which is the equivalent of your spark plugs. There's definitely a harmonic thing. There's this flashing, pulsing thing, which is often observed in these things going on, because without a vibration, there's no amplification. It can't be random static white noise power. It has to be a pulsing power, so that as you send new energy in, you hit that same pulsing harmonic and the energy level ramps up and creates resonance. And that resonance is where the gigawatt energy comes from. Well, the gigawatt energy comes from fusion. The initial heat that boots the fusion comes from plasma, superheated plasma. So there, one thing hands off to the other, plenty of parallels with the modern combustion engine of the car. Element 113 even fits in, because you want a unstable high, you're not going to put liquid helium in this, liquid hydrogen in here to feed the fusion. It's not like you're going to have a super cold tank of liquid hydrogen to keep putting in more hydrogen to become helium. You're going to have to get rid of the helium somehow. That's another story. Maybe it'll add to the buoyancy of the outer chamber, I don't know. But you are going to need to put new hydrogen fuel into that inner chamber, and that could come from element 113, because you want something that's stable, that keeps shooting off alpha particles. And what are alpha particles but hydrogen? Element 113 actually has a purpose. The UFO superfuel of Harv's laser actually fits into all of this. Is not deuterium on its way to becoming helium, and it's not H3, but it at least is a plausible source of an ongoing source of hydrogen to keep the fusion reactions going. UFO technology 101. The math behind this, the theories behind this, started with a gang of quantum in the early to mid 50s. By the late 50s, there were probably designs. Technological readiness proceeded from it's a good idea of like, oh, here's a Casimir force, to two, going, here's how we would test the Casimir force in the lab, to three, here's our little nanoscale seesaws and spheres that prove that there likely is a Casimir force or something like it. And then there's a divide between 3 and 4. Once you prove that the Casimir force is real, how do you do anything with it in a practical way? Getting it into a lab, getting it out of the realm of super science and into the realm of normal science. Most things don't do that. Most things don't pass over from the technological readiness 3 to 4 divide. Most things die in TR3. And most of this tech that I'm talking about, a lot of scientists would admit it's feasible, but it's dead at TR3. But it can't be forever. Some of these cross over into TR4 in our lifetime. We get free energy, we get some form of anti-gravity in our lifetime. Oh, let me just talk about the third way you go with that fusion chamber. It's having two additional chambers, or possibly 2 chambers of this fusion with alternating pulsing, something like that, spinning in a magnetic field. I don't claim to understand this, but it's another one of, I don't understand any of this, honestly, but it's another one of Salvador Payas's patents. And it has to do with not flux, quantum flux pinning and the magnetic highways through space, non-anti-gravity, very mundane stuff. High school experiments taken to the next step by playing the role of the neodymium magnet by the empty vacuum of space by just applying enough energy. Has to be extraterrestrial. It's nothing we could imagine or engineer on our own. No, we imagined it in the 50s. We engineered it in the 60s, but came up to the TR3 to TR4 divide for that, needing powerful supercomputers, among other things, right? Even helicopters have that stability problem, that third, tail, that third propeller for stability. It's a human constantly adjusting that third tail, which is why helicopters don't always keep spinning around. You've got a propeller lifting you. Why doesn't that propeller, through fiction, there's a lot of fiction, there's a lot of fiction in friction, or is it friction in fiction? There's a lot of friction in the, bearings where that propeller's spinning, which would cause the whole helicopter to spin. So there is a counterbalancing, differently oriented tail propeller on a helicopter to create that stability. The role of the computer is generally played by the helicopter pilot, but does not need to be. It can just as easily be a computer. That kind of stability is what had to be achieved with these Tic Tac devices, so they don't just fly off the table and smack into the wall. So that takes us from the 1960s to, say, like the 1990s, where the sightings of the Tic Tac versions of UFOs started to increase. The classic discs, the classic UFO discs, the flying saucer, started to diminish, and the cigar-shaped things, the Tylenol-shaped things, the Tic Tac-shaped things started to increase and become more commonplace, and then pilots started seeing them like every day, every time they went out. That was the 90s. Enter the 2020s. How many years later? Well, from the 90s to the 2020s, it's 90s, 2000, 2010, 2020. That's a 30-year period. Take the 70 years from the gang of quantum after the atomic bomb to today. That's 70 years. Knock those same 30 years off. 60, 50, 40. 40 years. The same amount of time it took from atoms are real to here's a bomb to quantum foam is real, virtual particles are real, to here's levitation, to here's a flying Tic Tac device, and then things go from TR4, so it achieves TR4 once the computers give stability, and it can lift off the table and not fly into the wall. That happened in China, that happened in England, that happened possibly in Israel. Who knows? Who knows? I'm saying it like it happened, but it could have happened. It could have happened in one of the states that can take the work of the Gang of Quantum, move things from TR3 to 4 as computers became ready for prime time, and then keep it a tightly held state secret. TR5, TR6, and TR7. From technological readiness 6 to working practically in a lab where you could really use this thing. You're convinced this thing could have commercial application if only you put it out in the real world and took account for all the factors that really happen. Oh, let's say when the rubber hits the road, there's the way. So from TR3 to 4 is like, Venture Brothers super science becoming actually usable. It's very hard to do. Quantum foam exists to hear some levitation, though we can't control it. That's TR3 to 4. It's a divide. It's a often insurmountable divide. It's the divide that keeps cold fusion from always being 30 years away. The next divide is TR6 to 7. All right. So you invent a new rubber that might be useful for tires. You create this rubber, you put it on tires, you put the tires on a test treadmill in the lab. You run it for hundreds or thousands, the equivalent of tens of thousands of hours, to see how quickly or not it wears out. And you're really convinced these tires could be on the road. So when the rubber hits the road, that's TR6 to 7, and that's often where the technological readiness scale stopped in the past. We have since knocked it up to 10, right? Because everyone wants a scale like this to be from 1 to 10. But the Tic Tac devices being witnessed in the 90s is approximately TR6 to 7. It's out, it's in use in real life, and the countries are bold enough to use them in not every day, but in spying missions, and taking a look at stuff over here on our side, because through, telemetry control from the submarines or whatever, they could control them over here in our airspace. So you do a few tests. Now, really, that sounds a lot like TR9 and TR10, but let's say these, states were highly emboldened and, put in a self-destructive device like Dr. Doofenshmirtz. How hard is it for one of these things to destroy itself? Everything in it looks like common parts. Maybe a titanium containment chamber for structural strength, and mirrors things, super reflective materials, and microwave emitters, even the nuclear material. Everything is fairly common. They might say, oh, there's a nuclear powered flying device that uses titanium, but from the wreckage it's going to look a lot like extraterrestrial UFO crash stuff, but it doesn't have to be. It can be completely terrestrial in origin, in design, and so what I'm saying is that in the same 40 years we went from TR1 to TR10 with the atomic bomb back in the olden days of 1905 to 1945, we could have gone from TR1 to TR, let's say, 7 in the 40 years from 1955 and the Casimir effect, 65, 75, 85, 95, to the credible sightings of Tic Tac-like devices by pilots. And then the next 30 years, the 90s to the 2000s, 2010s, and 2020s to where we are today is moving from TR7, Technological Readiness 7, rubber hits the road, to TR10. Still secret, but these things can be flown out in fleets by whoever controls them, used for whatever purpose, and then brought back. You know, honestly, as long as the fuel doesn't run out and there isn't some crazy, issue with the orientation and the relationship of the parts to each other, self-destruct can be simply as go that direction. And these things spiral out into space forever and, never get retrieved by the United States. So even if they're not our own, you don't have to blow these things up to even self-destruct them. You just send them off in a direction. Maybe the computers have to keep working, but the computers by this point are probably on board. And the math to do these counterbalancing of the spiraling effect of, the possible location of absolute positions in space, because the Earth is spinning on an axis, and then the whole Earth, which is spinning on an axis, is rotating around the sun. And then, the sun is in the is in our solar system, but it's at the center of the solar system. But our solar system is in the arm of the spiraling Milky Way galaxy. So who's to say what absolute positions in space are? Maybe the quantum loop quantum gravity. It should have been called quantum loop gravity. It rolls off the tongue easier. But the loop quantum gravity crowd has some ideas about this. And maybe they can take a crack at it. If absolute space is relative to like where we are in absolute space, that is such that when you polarize it, stays in a position relative to where we are, that would be wonderful, because the computers wouldn't have to do quite as much work to keep us stable, to keep things stable. And that could account for at least the Tic Tac and cigar-shaped versions of these things dating back further than the 50s. Because I know one of the arguments is that this goes back in time so far that it couldn't possibly be the outcome, the product of the Gang of Quantum, like I propose, and the output and the product of human beings and earthly design, like I propose. Some people just want to believe in the aliens. So honestly, if there's some other civilization out there that has just finish up that third scenario. When there's rotating chambers in a magnetic field with similar stuff going on, it emits gravity waves. These gravity waves can be used to deflect small asteroids according to the patent. Again, the Salvador Payez patent, right? That's one of the practical applications. So you can project a gravity field that can move things like a repulsor field a la Iron Man. But then it could also be used for anti-gravity as well, in a truer anti-gravity sense than these magnetic highways, by simply creating a lower gravity field in front of you, or a differently oriented gravity field in front of you, and then surging into it, falling into it, basically falling in any direction you want to fall by projecting a gravity field that simply has more power and energy to it than the gravity well of the planet you're on. So that's a second path to anti-gravity using these same similar technologies. I can't give you the thought experiment of these counter-rotating chambers as well as I can with the flux pinning mental experiment. Suffice to say that the Payez patent says it uses these counter-spinning chambers to achieve a sort of centrifugal stability, right? So where does this stability come from? If you're forever falling up, what keeps this thing from becoming all wobbly and crazy? It's because the thing that creates the field that allows you to fall up is also doing the gyroscopic, stabilization trick to keep you stable. I'm much more infatuated with the magnetic highways than I am the gravity fields. And in the Bobiverse, Audible, the amazingly written and narrated Bobiverse series, it even covers how the initial spaceships that took us into space were surge drives. But as soon as they discovered Casimir force Casimir force generators, they switched over wholeheartedly to them because they were, completely superior. In that, they could even give up fusion reaction. See, there's scenarios of this, which I haven't talked about on this video at all, where you can take away the fission-based starter, the fusion-based combustion engine, and replace it all with an infinite turbine that taps into the Casimir force by spinning wheels that alternate the Casimir force between repulsive and attractive forces, so that the wheels are always spinning, and then you can extract energy by traditional turbine means from that. Yeah, that'll be another video. So if you enjoyed me explaining to you how UFOs work, particularly the Tic Tac UFOs, and how after 70 years, people like Luis Elizondo saying, these could not possibly be of terrestrial design. I'm in the military industrial complex and I know. I would say to him, did you know that Alan Turing invented computers in real factual life through a physical machine that helped us win World War II before the Brits declassified it? No, you did not. And how many other things are like that? Would atomic energy still be secret if we didn't use it for a bomb? See, you can't keep an atomic bomb secret. You can keep anti-gravity secret. And why would you not? In fact, I would go as far as to say logic dictates that we should have anti-gravity by now, over these 70 years since, the atomic bomb. And I think it's even 80 years if you count between 1945 and 55. 45 was the bomb, 55 I think was the Casimir force being deduced by Heinrich Casimir. I gotta get these names straight. I really, that's a weakness of mine. It's another reason I'm not into the math of all this. But we've had basically the same amount of time they went from proving atoms are real to practical use twice over. They had 40 years, we've had 80 years, 70, 80 years. Where's my flying car, dude? We probably have them. It's hard for me to imagine. I don't think I'm in the realm of tinfoil hat wackos to say that the odds and probability from having proven the Casimir force going from, TR 2 to 3 has happened long ago with experiments. But going from 3 to 4, reasonably took until recent years because of computers. Going from 6 to 7 took until recent years because of computers and the comfort level of the people flying these things to take them out into the natural world, non-lab conditions. TR6 to 7 was the difference between the 90s to the 2020s. And now that it's, from the 90s to 2020s, it's really hard to imagine that they can keep the lid on this thing for that much longer because of the cameras built into our cell phones. You can't, they're not making them invisible. That's another video, invisibility, cloaking invisibility technology, right? It's real stuff, but, combining all these things together is just so hard to do. We haven't even done it with robots yet. We have the Boston Dynamic robots that can walk around, and do amazing gymnastics, better gymnastics. So we're far beyond getting a computer to walk, right? We can get computers to do superhuman feats that humans could never do. It's just a matter of power source to have them walking around in our everyday lives. We can get them to talk, merely Turing test convincingly, as we see by, these open AI APIs and, internet things you can talk to convincingly, as long as there's not really a human on the other side. Maybe it's all a hoax. But all you got to do is combine those two things. You got a walking, talking robot. You got Asimov's vision of the positronic brain robot, the Robbies, who can be doing errands for us. We have that in two separate forms today. There's a lot of things left. It's all in the nuance. Combining these, okay, it's an hour and 30 minutes. There is where I should wrap up, because I could just go on and talk forever. I'm here just having crossed over the Verrazano Bridge. I'm on my way to pick up my kid, and I'll be having to wrap up real soon anyway. So I hope you enjoyed my explaining to you how you don't need aliens to explain most of what we can verifiably, with high credibility, observe today. The kind that the commander of the F-18, F-18s off the USS Nimitz have observed. The stuff which is pretty difficult to deny exists. These, Nazi UFOs and these saucer-shaped ones and the Harv laser captured UFOs is like another story. And I'll try and get to that, and I'll get to all these other things. Give me your feedback if you like these long rambling videos that I do, to show you why, through my mind, I get pissed off every time people go, this could never be earthly technology. I've never seen anything like it. It's centuries ahead of where it should be. Oh, no. We are centuries behind where we should be, given stuff we actually verifiably know. The Casimir effect and this virtual foam particle stuff is real. Just the significance of that alone is profound, without even mentioning that, we're on the edge of faster than light travel through warp fields, if any of that bears out. Another news story that came out directly tied to these Casimir force experiments that further verify the existence of the quantum foam. But that's what I find most impressive and important at these days. If quantum foam exists, then it's polarizable. If it's polarizable, then it becomes a not a natural magnet, but it becomes an electromagnetic magnet suspended in a fixed point in space-time. And if you bring a superconductor near that, you get the quantum phase locking effect. And if the thing creating the energy to magnetize space is attached to the same device as your superconductor, you've got levitation. And if that gets wacky because that absolute position in space is a lot different than what you think it is from your human perspective, then you got computers to compensate for how those fields are generated, so that you can keep following a predictable path. And here I am in my old-fashioned combustion car, the best you can do. I don't care what Tesla car, Lamborghini, Audi you're driving, nothing beats a Jeep. It helped us win several wars. It's the most American car in existence, even though it went through the hands of the Germans and the Italians. It keeps coming back to us as the car that needs the least maintenance. And maybe I'll go for sponsorships. Hey there, Chrysler or whatever megacorp owns you now. I think Maserati or some Italian conglomerate, I don't know. Sponsor me. I'll talk up the Jeep for you. And the insurance people. I got that $3,000 lifetime warranty on my Jeep, so that no matter what goes wrong, so long as I do regular maintenance, they pay for all parts that wear out. It has to be stuff that is broken through my own fault that I pay for. I think it's called Mopair insurance or something. So there's some really good deals in life out there. And even though I can't have my flying car and my super science, I do look around and make a study of what's best. So if I go and really monetize this stuff in any significant way, I hereby invite any of you sponsors who might be looking for slightly less than tinfoil hat pontificators, pundits, verbal vomiters, to narrate how we are going into the future right now, today, through super science becoming real, as things, primarily go from TR3 to TR4 and TR6 to TR7, then I'm your person. Reach out to me. I love this stuff. 1 foot in sci-fi, 1 foot in the science news articles of the day, 0 foot in the actual real math and science behind it, because there's not enough feet on my body. But I think I spin a pretty good yarn. I think I present a pretty good thought experiment. And anyone who made it actually this, hour and 35 minutes in, let me hear from you. I hope you hold in your mind a very plausible scenario as to why these not anti-gravity Tic Tac flying devices are probably very real, very terrestrial in origin, and very late to the game in as far as when we could have had them. Thanks for joining me. Hope to see you again soon, and don't forget to subscribe.